All right, so today we'll be able to determine, like I said, intervals in which a function is increasing, decreasing, or remaining constant, as well as being able to identify local and maximal, extrema, and things of that nature. Okay? Not only that, we're also going to determine rates of change, which you already know pretty well, you just don't know it yet. Okay? But you just don't know how well you know it. That's what I mean by that. So, increasing and decreasing behaviors. Like I said, a function can increase, decrease, or remain constant over a given interval. This interval is in relationship to the x-axis. Okay? Not the y, but the x. So if you need to make a little mental note, go ahead and do so. The interval is in relationship to the x-axis. So first we figure out if it's increasing and decreasing, and then we look at the x-axis to figure out that interval. Okay? Constant. What does it mean to be constant? Stay the same. Neither going up nor down. I'm just staying straight, horizontal. Now points that change from increasing to decreasing or decreasing to increasing are known as critical points. Okay? A critical point can be a relative min, it could be an absolute min, a relative max, or absolute max. And in general, the term for min-max is called extrema. So when you hear me say, okay, what's my extrema? Do I have an extrema? I'm talking about max and mins, and specifically relative or absolute. Okay? So let's talk about the difference between relative and absolute. Absolute. The very highest point on the curve, or the very lowest point on the curve. Okay, that's absolute. Looking at this makeshift drawing I did over here on the board, do you see any absolute maximums? Okay, where? The right maximum, right here. And it's an absolute max because, again, it's the highest point on any part of this curve. This max right here is relative. Okay? Simple as that. This right here, it's not a max, it's a what? It's a min, and it's the absolute or relative? It's relative. It's not absolute because you see these ends right here? They keep going. So technically, those ends are the lowest point, not that min there. Does everybody understand that? It should be familiar. We kind of went over this in algebra 2 just a little bit. Something that you might not know of, though, depending on if you say you were going to look for extra resources or something, you might find local minimum and maximum instead of relative. Okay, local means the same thing as relative, okay? Just different versions. Got it. Yeah, this nice little diagram, this man pointing to this curve. Different points are increasing or decreasing. Now, the interval in which they're increasing or decreasing is in relationship to what axis? X. So when you give me the interval of where it's increasing and decreasing, you look at what axis? The X. Okay, let's give it a try. So, I see that I'm increasing from this blue dot to this blue dot. And that interval is from what to what? -5 to -2. Not -3 to 1, but -5 to 2. Yes, ma'am? I do have to report today. All right, so I'm increasing from -5 to -2. Now, the whole parentheses and brackets thing, we don't have to worry about here, okay? We're literally just talking about, okay, from where to where. All right, from where to where. We don't have to worry about brackets or anything here. Then I remain constant. Who can tell me what I'm constant on? From what to what? Wait, oh, I wanted to raise a hand. Oh, so, okay, wait, so like half the class was saying, but when I asked for a volunteer, here, I got from -2 to 1, yes, okay? And then I keep going up some more. Who can give me that interval? Raise hand. Steven. Say again. 1 to 3. Now, when I do have multiple intervals of increasing and decreasing or constant, I still connect the intervals with what? the u. So I still need that u there. And lastly, I'm decreasing. Who can give me that interval? Raise hand. Adriana? 3 to 5. So the interval is relationship to the x-axis. Yes? Question?
Would it be negative 5 or just regular 5?
Just regular 5, because remember we're looking at the x-axis. Other questions? All right. We're going to, same thing. Here's some more functions, okay? First one is an example of a rational function. Okay? Remember, an extrema occurs when there's a critical point. A critical point occurs when I'm going from increasing to decreasing. Just to recap. So, I got arrows here. I don't know if you can see them, but that means they keep on going in these directions, okay? So keep that in mind. This first little bit. Increasing or decreasing? Decreasing. Because when I go this way, because you read from left to right, I am going down. So I am decreasing. Who thinks with the raised hand they give me that interval though in which we're decreasing? Remember, it's in relationship to what axis? X. Alexis?
Negative infinity to 0.
Very good. Negative infinity to 0. Because I'm coming from some negative x value that's like super large towards negative infinity, going all the way up to 0. It may look like it's flat, but this is a rational function. It's getting really, really close to 0 over here. It's really, really close to my x-axis over here. So it's never flat. It's just slowly decreasing. Yes? Because we do have a break here. There's a break in our graph that's caused by what? Anybody know the name of that break? It goes up and down. It is the y-axis, but there's something there that causes this curve not to cross over asymptote. Okay? That's why, because there's an asymptote there, we do have to break up our intervals. That's a good question. The other piece of this graph, increasing or decreasing? Decreasing, so I have a u. Who can give me this last interval? Raise hand. Maybe I'll start calling on some folks. Don't be shy. I'm pretty sure you got it right. Shannon?
0 to...
Yes. Very good. Do I have an extrema? What do I mean when I say extrema? Max or mins. And remember, a max or min occurs if I go from increasing to decreasing or decreasing to increasing. Do I have that here? No, it's just decreasing the entire time, so I have no extrema in this particular example. Will it happen every time? No. We'll want to make sure that we do answer the question completely. You guys want to try the second one on your own, or you want to do it together? Want to do it together? Yes. Here we go. We have a quadratic here, okay? Going from left to right. I am coming from up here, going, what am I doing? I am decreasing. And I'm trying to figure out the interval in which I'm decreasing. Remember, the intervals are relationship to the x-axis. Where's it coming from? All the way to, it is 2. The reason why it's 2 is because of scale. To try to throw you off there, please make sure you check your scales if you ever have a graph, okay? It's decreasing from negative infinity to 2. After 2, until when? Any extrema?
Yes.
What kind? It's a min and it is absolute because it is the lowest point on this curve And when you do identify absolute maxes and mins and relative maxes and mins, you need to actually say what that point is. So what is this point? I know it's 2. Negative 9. Okay? So, not every function can be easily seen where it's increasing and decreasing like those other ones were. You know, they lied on a good point, you can tell. So, when we can't necessarily see it easily, we have to use our graphing calculator to get the exact intervals, okay? Now, looking at this curve, how many mins do I have? 2. How many maxes do I have? Careful. Maxes. What? 1. 1, because technically those arrows mean they keep going, so they don't ever, curve back around. For this first min, is it absolute or relative? Absolute. And I can't really tell what it is. I can probably guess, but I can't really tell. So we're going to have to use our calculator to find that one. Is this a relative max or absolute max? It's relative. And you know that because those lines, those arrows mean that this point's higher than that. And that last min is a what? Relative. I can tell what that point is though, can't I? What's the order pair for that point? 1, negative, careful, 6. The x's are by 1, the y's are by 2. Just be careful, okay? So, we can look at this graph and see that from up here to that absolute min, increasing or decreasing or constant? I'm decreasing. From this absolute min to this relative max, I am increasing. From that relative max to the relative min, I am decreasing. And then the last part, I am. But my only issue is to identify where those intervals are, I need to know what that absolute max, absolute min, and relative max points are. So here we go. Calculator's out. First thing you do, you turn it on, and you hit your y equals button. If there's anything in any of them, go ahead and clear them out. You should see y1, y2 all the way down, and plot 1, plot 2, and plot 3 should not be highlighted. Is anyone's screen not look like mine right now, besides the color? Great. At any point in time, you're not with me, let me know. So what we're going to do is we're going to type in our function into y1. Okay, we're typing that x to the 4th minus whatever. So to get that, the x is right here, located beside your alpha button. And to get the 4th power, you press the caret button, which is right above the division symbol. And then you type a 4. Now, if yours doesn't automatically create an exponent, it just does like the actual caret symbol, that's fine. Keep typing. However, if yours does what mine just did, you have to press the right arrow button over to bring it out of the exponent. So type in the rest of the function, okay? What's the rest of the function? Minus 5. Okay, we got it? Now before you click graph, you need to fix your window, because if you're using one of mine, who knows what that window setting has changed to, okay? So we're going to change the window so that our screen looks exactly like the picture we have. So to do that, we'll go to Window, which is right beside the Y equals button. And we're going to type in a Y min. Look at your graph. Like, look along the x-axis. What's the smallest number on the x-axis? It's a negative number. Negative 4, maybe negative 5. Yeah, this point right here. Negative 5. What's the x max? Positive 5. So once you type in negative 5, you click enter to x max and type in 5. XSCL stands for my scale of my x-axis. Did it go by ones? Yes. So click enter. My y min. Negative 10, okay. So if yours is not negative 10, change it. What about my Y max?
10.
My Y scale though goes by what? 2. So you make the changes, and now you click graph. Graph is the button at the end, and you should have the very same picture that is in your notes. Yes. Anybody not here? Alright, so we know this relative midpoint right here. We figured that out already. That's the one that we could see. It was 1, -6, right? But we don't know this max or this min here. So this is how we figure it out. And we need these to determine our intervals. So we press the second button, and we press the trace button. Trace button is located right beside the graph button. And you should get a list that says calculate. Right? Now we're gonna find that minimum, that absolute minimum. So we're gonna go down to the option that says minimum. You can arrow down and click enter on 3, or you can just press the number 3. And this should be on your screen. Are we still okay? Now it says left bound. Left bound means you need to go to the left of that minimum. So you're going to press the over arrow, and you're going to see your little blinking cursor move. Now it doesn't need to be right to the left of the minimum, it just needs to be to the left of the minimum. So it could be here, it could be here, it just needs to be to the left. Does everybody understand what I'm getting at? Click enter. Now, your calculators, especially if you're using mine, are not going to have this dotted line feature, but it should have that little arrow, does it? Very good. Now it says right bound. So that means we're going to go to the right of the minimum. Now you don't want to go like all the way up here, because now you're sitting really close to that maximum, and we don't want the calculator to get confused, because it's very easy for these things to get confused. So just go just to the right of that that minimum, and click enter again. Another arrow will pop up, and basically if I were to drag my fingers down, my minimum should lie in between those two arrows. It says guess, and when I click enter, the calculator does all the work for me and tells me the exact point, or the more exact point than I would ever find for that minimum. Huh? It is. We're going around to 2 decimal places. We're going around to 2 decimal places, okay? So, my absolute minimum is at the point negative. I forgot I just said that. Help me out. 1.3 comma negative
8.51.
And remember, I need that point to figure out my intervals, okay? We're going to do the same thing, but this time we're looking for the maximum. So how do I get back to that list? No. Second trace. Remember, y equals is where I type my function is. Graph is where I see my graph. Second trace takes me to my options. So I'm looking for a maximum, so I can either press 4 or go down and click enter on 4. And it's the same process. Left bound. I need to go to the left of that maximum and click enter. Right bound. I need to go to the right of that maximum. Click enter. Double check. I need to make sure my arrows, my maximum falls in between my arrows, which it does. Click enter on guess. There's the order pair for my maximum. Did anybody not get that?
Yeah.
Wait, like you did not get it or you did get it?
No, I got that.
Okay, cool. So here we go. My relative maximum is located at 0.17, comma,
Negative 4.92.
and now I have my order pairs for my maxes and mins, And now I can do my intervals, where it's increasing and decreasing. Now we already labeled where it was increasing and decreasing, so we're okay, right? And when I do the intervals, it's in relation. I'm looking at my x's, okay? Looking at my x's. So first I am decreasing from 2 negative 1.3, because that's the x coordinate of that minimum. Then I'm increasing from negative 1.3 to 0.17. Then I go back down. So it's a union with my decreasing. I'm decreasing from what to what? 0.17 to 1. And then I'm increasing again, so union, from, there it is. We're going to do this one. Now real quick, I have this point. I'm going to clear this out, y'all, so we can see this. That point, we already know it. Is it absolute or relative? Max or min? And it's located where? If you did the whole calculator thing, you'd be wasting your time because it is negative 1, 1. But this other point, is it relative or absolute? This is the one we don't know, so let's go to our calculator, let's figure it out. I go to y equals, clear out that function, press the clear button, type in the new one. Do that now, type in the new function.
Plus x squared. Minus x.
Before you click graph, check your window. Press the window button. Do I go negative 5 to 5 on my x-axis? Is my scale 1? What's my my y's though? Negative 5 to 5, and my scale is 1. Do you guys remember the process to find the minimum? Go ahead and do it. Find the minimum. Find the minimum. It is second trace. Second trace. The minimum.
This is absolute. Because of all
0.33 and negative 0.19.
yeah.
Yeah.
Absolute.
So now that you know your maxes and mins, you can do your intervals. You are increasing on this interval, decreasing here, and increasing again. So you need the union when you do your increasing intervals, okay? I'm going to trust that you guys can do that because I'm running a little short of time, so I want to make sure I get to the last thing, which, like I said, is something that you've seen before. Average rate of change. Not in those words, but you've seen this. The average rate of change between any 2 points on the graph of F is the slope of the line through those points. Average rate of change is basically the slope for a curve. Okay? Old school classic slope, y2 minus y1 over x2 minus x1. That's for 2 points that are on any one line. But this time we're actually trying to figure out the slope for a curve. You can't really do, that's why it's called average rate of change. This is the formula. Okay? Please make sure you write it down. Should look familiar. What does f of x mean?
Y.
Y. So f of x2 is basically y2. F of x1 is basically y1. This is old school classic slope. It's just this time it's for a curve versus a straight line. Okay? So to find your average rate of change for a function on the interval, they give you an interval. Intervals are in relationship to what axis? The x. So this is your x1 and this is your x2. It's not x and y, it's x1 and x2. So you already got the denominator in this problem. -1 minus -2. The thing you don't have is your numerator, but it's very easy to find. To find f of x2, that literally means take x2 and plug it into your function. That's all that means. To find f of x2, you just take x2 and you plug it in. What's -1 cubed? Times a negative on the outside. What's 3 times a -1? So all I'm doing is I'm trying to find f of x2 that goes into my formula. I take x2, which was -1, I plug it into the function, and I simplify. What's 1 minus 3? This is f of x2. That's what I got when I plugged in x2 into my function. I do the same thing for -2. I plug that in. -2 cubed. -8 times the negative on the outside. 3 times -2. 8 minus 6 is. So that is f of x1. So all I did was just plug in and evaluate. This is what we did on Monday. Or last week. What's 2 minus 2? 2 negatives make a? -1 plus 2 is? So this is -4. The average rate of change for this function on the interval -2 to -1 is -4. That means that the slope is negative between these 2 points. And if it's negative, that means from -2 to -1, my function is doing what? It's decreasing. If it was positive, it would be increasing. And if it was 0, it would be what? Constant.